warm welcome to everybody joining us on our Ekahau webinar series. Today, we are going to be covering Wi-Fi best practices. And let me tell you, ladies and gentlemen, I hope you're ready for some audience participation because pretty much the whole webinar is going to be live demos, analyzing lots of really interesting data. And Mac and I are going to be asking you a lot of questions, and we're going to want you to participate in looking for things that could cause us some issues with Wi-Fi, how we identify them, how we stop them from happening, and then what are the best practices. So, Mac, why don't you do a quick round of introductions?
Absolutely. So as always, it's Matt and I, Director of Product Marketing in ECSC, and Matthew, Senior Director of Product Marketing in ECSC, joined by wonderful wireless Stu and Dale that will be helping us out with questions and running the webinar. So thank you very much, guys, for being here, and let's crack on. So Matthew, tell us what's on the agenda.
Well, today we are going to be covering everything that you need to know to how to optimize your existing Wi-Fi network. So perhaps you've got a deployment and it's not working too well. We want to figure out how can we make improvements without having to relocate access points or run new cables and install some additional access points. What are some of the really key things that we need to identify to fix here? We'll also show you some things that you can use to design new Wi-Fi and the best practices to ensure that your Wi-Fi network is smooth and operates very well. Lots of things to take into consideration here, and might be revealing a little bit of what's to come in the show, but the way you physically mount your access points can have a massive impact on the performance of your network. Then something that is really important these days is making sure you've not only got a really well-designed Wi-Fi network, optimized Wi-Fi network, but really key that we have a secure Wi-Fi network. So we're going to be showing you some best practices for making sure your network's nice and secure. And we've also got lots of great takeaways for you on the best practices on ways you can configure your Wi-Fi network as well. So that's the agenda for today. And we actually have a bunch of poll questions that we wanted to ask you all on the webinar. So Mac, why don't you let everybody know about this first one?
Absolutely. So, guys, we will be probably, depending on the poll answers, hosting a Wi-Fi day. And the question is, would you be interested in attending Wi-Fi day in person in States in September? So typically Wi-Fi day was a virtual only event, and we are considering, serving some free beer, good food, and most importantly, amazing Wi-Fi presentations. We might have some arcade machines. Well, I don't know about that.
I can see a lot of people getting excited in the chat with some capital Bs. And I just want to make sure I call out, make it clear as well. If we do go ahead with it in person, we will stream it live as well. So even if we are going to be doing it in person, our plan is to stream it live to you, just like we do at every annual Wi-Fi day as well. So can I change my answer after hearing free beer? Of course you can. We will add that to the list.
Come on, guys, keep answering. We want to get almost everybody answering this question. This is we need all your participation here.
Okay.
And guys, I can see
Nearly.
some questions. Well, not questions, like comments about the cost. It probably will not be too expensive to attend. Okay, so we are not thinking of making money out of it.
Yeah, it will be a very low cost event to attend if we do go ahead in person. Obviously, the virtual aspect of it would be free as always. So let me end the poll, share those results with you, and if I could do some quick maths in my head and add A and B together, that's like what, 64% of you are basically saying that you would be interested in attending an in-person event. Of course, we would share more specific dates and locations when we get a bit closer to it, but we just wanted to see now, ask our amazing webinar audience if this is something that you'd be interested in, and a big chunk of you have said yes. So we will do everything we can to try and make that happen. Okay, that was the first question. So the next question that we wanted to ask everybody was, how important do you consider spectrum analysis when performing Wi-Fi surveys? Let me just launch that question.
And also for those of you that have never done spectrum analyzers, guys, is a device inside your measurement device, a module that can see here RF energy, so everything, Wi-Fi, non-Wi-Fi, RF interferers, microwave, wireless radios, access points, excessive BLE, and motion sensors, and leaky fluorescent lights. And by looking at it, you can understand how it will affect or already affects your Wi-Fi, not only design, but also performance.
Yeah, no, that's a really great explanation of that. And we have got lots of people answering the question. Oh, and someone said in the chat, help me find some hidden devices on networks. Love the Psychic too. Yeah, I mean, that's one of the really yeah, one of the really key things about the Psychic 2 is it's got that integrated spectrum analyzer. So just from walking your environment, not only do you detect all of your access points, your neighbor's access points, but it will detect and locate any of those devices, just like what Ziva mentioned in the chat. If you've got some bad, naughty interferers there operating in those Wi-Fi frequency bands, we'll detect them, show you where they are on a map, exactly where they are, the impact, and then you can remove them. So let me end the poll because I'm glad to share these results with you and see that a massive percentage of you all agree that it's really important to perform spectrum analysis as part of our Wi-Fi surveys.
And then, yes, you will be able to spot both Wi-Fi and non-Wi-Fi but wireless security cameras with Spectrum Analyzer. You will be able to see the spectrum utilization from the camera if it's Wi-Fi, and you will see that from network cards as well. So you'll see on what channel, what technology, and stuff like that. And if it's non-Wi-Fi but still wireless, you will see that as well. So that might be helpful.
Definitely. Okay. Next question then, Mac.
Yes. So what is the biggest difference you have encountered in expected wall attenuation? So for example, you are doing a Wi-Fi design and then you are knocking on the wall and you conclude this is a dry wall, but in fact, it has a double brick inside and the attenuation is not 3 dBs, but 23 dBs instead. How many times has it happened to you?
I'll be honest, this really caught me out bad one time. I thought there was a bunch of meeting rooms in a row that were all just drywall. It really looked like drywall, and that's what I drew in my Ekahau project file is 3 dB drywalls, and I just needed like 1 AP to cover a few of these meeting rooms. And then when the Wi-Fi got installed, people were complaining about the performance of the Wi-Fi in these meeting rooms. And I thought, oh, no chance. Wi-Fi I designed? No way. And then yeah, it turns out the what I thought was drywall actually went drywall, brick, drywall, and it was closer to like 16 dBs of attenuation rather than the 3 dBs that I anticipated. And I had to retrospectively go back, install some additional access points, which meant running more cables and wasn't great. So has happened to me. Maybe it's happened to you. Let me end the poll and share the results.
I've done it
And
more. If you're in the city center, big cities, they tend to have bomb-proof glass all around. So it might look like 3 dBs glass, but it's like, 33 dBs EM shielded bomb-proof glass that you wouldn't expect.
yeah, and it's difficult, right? If you're doing a massive survey of a big environment, going around and checking every single wall to test for the different attenuation of each wall, because you could even have some dry walls in your office space or whatever environment it is that they could actually be different types of drywall with different pieces of filling in there. I can see some people in the chat as well saying that they've come across this and it can be a different attenuation level, which really impacts the coverage of the access points as well. So it was very kind of majority going towards between 4 to 6 dBs that you kind of seen, but there was a big percentage as well for the higher amount, like 7 to 9 or even 10 plus dBs. So really interesting. Okay, our final poll question for you before we dive into the content is uh, let me launch it for you. Is how often are you designing a network that has no existing Wi-Fi? So what we mean by that is, do you ever go somewhere where you're going to perform a wireless survey or do a new design and there's not any existing Wi-Fi there at all, either from a previous company or maybe some from the access points they had before? Is it often that you're going to do a Wi-Fi survey or a design for someone and they have completely no Wi-Fi around for you to use?
Interesting. We see our answers live. It's interesting to look at. Okay, tons of you have answered this question.
Yep.
It's enough. So let's share the results. So guys, the conclusion is that more than half of you is not designing for spaces that don't have existing Wi-Fi, meaning most of the designs are really modifications or redesigns, right? Not a fresh greenfield designs without existing Wi-Fi network, which is interesting to see.
Mm-hmm. Okay, cool. Well, you might be thinking, why are they asking so many poll questions at the beginning of this webinar? And kind of leads us up to this, because, ladies and gentlemen, really exciting. We have some product news to announce. And it's going to be announced in 2 weeks' time on our next webinar. And there may be some clues from some of those questions that we were asking you as to what it might be. So if you want to make sure you find out this news early, sign up, use that QR code, and we will be previewing a brand new product for you. And it's very exciting, and it's going to be incredibly fast and a new way to supercharge your Wi-Fi designs or redesigns or upgrades or optimizations. Maybe I shouldn't say too much more.
Yeah,
Maybe we should wait.
One more thing, a little one, as Anders has caught you on. Yeah, super small, little tiny thing. Great product, big announcement, guys. It's probably bigger than we make it sound. So yeah, you will see in 2 weeks.
Mac is trying to get me fired with making that kind of comment and knowing how hard it would be for me to resist making another comment back to that. So let's move on. What is Ekahau all about, Mac?
Okay, so for those of you that never used Ekahau before, many years ago, Ekahau was a design tool, but Ekahau today is not only a design tool. Designing a new network is just a small portion of a Wi-Fi network lifecycle. It's equally important to keep the network in a great condition, great performing, and secure at the same time. So Ekahau is amazing for designing new Wi-Fi networks, optimizing your existing Wi-Fi networks, and securing all Wi-Fi networks, new or old. And as you will see today, we will be going through some demos to show you how to do all of this, best practices. Even if we don't have a demo for security, for example, we have prepared a chunky slide that shows you, you will see later, best practices on a single slide. Okay, so let's start with optimizing existing Wi-Fi networks. What we are about to do is to show you Ekahau AI Pro and discuss the project. This is the real project, real survey that me and Matt have completed together. And we would like you to find out together with us what's wrong with that particular network and how to fix it. So Matt, tell us more about it.
Yeah, let me just paint a bit of a picture for you and a bit of background to this scenario here. So like Max said, this is a genuine survey that we went and did for someone in central London, and they called us out because they were having reports that the Wi-Fi really wasn't working. It was super slow, unusable. They couldn't make video calls, couldn't even do voice calls. Even just trying to load anything was really bad. And the thing that shocked us most is that the users hadn't even moved into the office yet. So the people that were complaining about the Wi-Fi was actually the team going in to set up the office. So they were putting up the desks, the screens, the whatever. So that meant that like not even like probably 1% of the workforce were even in using the Wi-Fi, and it was unusable, which was pretty scary. So why was that? Well, we're going to take a look at it together and analyze the file in AI Pro. But what it drills down to is that the person that did the design for this network, they never actually ever went to the site. So they never even did a predictive model in Ekahau. They never did a survey. They didn't follow the best practices on what you should be doing when you are installing your access point. So this isn't a case here that, oh yeah, it's just Aruba access points, Wi-Fi sucks, or Cisco or whatever. It's because the person that was implementing it missed out on a bunch of best practices and the steps that you should take when you are installing a Wi-Fi network. Ekahau goes hand in hand with the manufacturer APs to ensure that when it goes in, it's going to work and work for best practices. So the fact that they never went to site and all they did is they literally handed over a floor plan with some dots on a map and just gave that to the installation team with no clear instructions. So let's take a look at this together and see if we can identify, some of the issues that they run into and why. So I want this to be as live audience participation as possible. So I'm going to be throwing out questions to you. I can see the chat. Please just respond in the chat when I ask you some stuff, and we'll take a look at some things together. What Mac is going to be doing in the background, he's going to be writing down all of the problems that we find for this project, and then we will look at how many of the things we uncovered. So let me show you. So this is Ekahau AI Pro. And this is a survey file from the site. And we're looking at 2 floors here. So we've got the first floor and we've got the lower ground floor. And what you can see here is we've got the access point for the network that's deployed. And we can see the coverage coming from the access points. For now, Don't worry why some of the access points are in slightly different colors. They are all the same model access points from the vendor. It's just a reminder for me because I want to show you something specific to those access points. So from what we can see here, when you're analyzing a Wi-Fi network, what would you say is like one of the first things that you would go to check? So we've got this file now, we're analyzing it together. We can see where the access points are. Let me know in the chat, what's one of the first things that you would like me to take a look at? So we can see where the access points are currently placed. So signal strength and then channel interference and channels. Okay, so one of the things I actually do like to do is I like to click on each access point and look at the individual coverage coming from each access point to see, how far does it cover? What does each access point, cover in the environment, and does it look like it's right? Is it really in that position, etc., etc. So I do like to just click on the APs, see how far they can cover and what's going on. So when I look at this, I think we'll start with coverage first, 'cause I can see a lot of you talking about coverage and like what are the requirements. The requirements were that Wi-Fi just needed to work. It was so unusable. We want to do typical office applications, voice, video calls, emails, roaming, etc., etc. So from looking at this primary coverage, what we're looking at right now, it looks kind of okay. Like the signal isn't too bad from the primary coverage. However, if I change the view now from primary coverage to secondary coverage, what we can see is that there's a bit of gray that creeps in now. So why do we need secondary coverage? There's two big reasons why we'd want to have secondary coverage. One, for redundancy. If we were to lose an access point for whatever reason, there'd be enough coverage from a nearby AP to cover that failure. And two is for roaming. So if our access points can hear each other, they can do something that's called neighbor reports, inform client devices about what channels they're using. So it speeds up the scanning time and then traversing between access points. So what we can see here is actually there are some areas where they're gray, and it's some issues with the secondary coverage. If you have issues with secondary coverage in the corners of your deployment, it's not so much an issue for roaming because you're not going to roam out of that office. However, if you do have an AP failure around here, it is going to be a bit of an issue. So the area that I find most concerning is around here. And we've got a lot of gray around here. And the actual reason for this, you might notice that we've got something on the floor plan. It's called a map note. So one of the things that we absolutely love about the Ekahau survey app is it's so easy to take pictures and add notes and give context for what you're looking at. So what I can do here is if I click on this and open the notes, what we can see, if I show you this, is this access point wasn't powered on. And I don't know about you, but typically if I'm installing an access point on this floor, I want it to cover the floor that I'm on. It looks like they may be trying to cover the floor above with Wi-Fi. So not too sure that was a great way to install the access point. So that not only was it not on, it was also not installed too well. But to remember, like what I was saying earlier about giving that context, you can see here the office isn't even set up yet. The screens aren't in, and the main users are not even in the office yet. So yeah, not really the best way to install that access point. So whilst we're on the subject of physical AP installation and how much of a big role that plays in the performance of your Wi-Fi network, let me show you a couple of the APs that were actually on and were broadcasting. So if I show you the picture note that's associated to this access point, how do we feel about this location of the AP where it's been installed? Okay. Okay. I'm just watching the chat. Yes, not too great. I tend to agree that it's not the best. I mean, like, number one, like, why did they not just put it on the cable tray, like near the CCTV camera? You got so much metal piping here in the cable tray, but look at this big bad boy, this massive steel, like, or concrete beam coming down from the ceiling. That's going to be a big attenuator of the Wi-Fi. So like, I don't blame the installation team here, because they were probably they were just literally given a floor plan with some dots on the map, and they've done their best to just put the AP in that specific location. There was no clear mounting instructions. So like, what would be the best practice thing to do here is, like, at a minimum, move it to the cable tray. But ideally, we want to suspend it down away from these materials, like at least like by a drop pole, and get it 1 meter away from the things that can cause like corruptions to our frames. Because let me show you an access point. You're probably thinking, oh, surely maybe this was just a couple of APs that were having this issue, but I'll show you my favorite one. It happens to be the one on the lower ground wall, and I'll show you the note. And let's look at this one. And how do we all feel about the position of an installation of this access point and what it's surrounded by? Okay. I couldn't agree anymore. Me and you probably think me and Mac set this up. So like, this is great, like, you know, bad Wi-Fi we can show, but this was genuinely an actual physical installation of a network that we went to go and resolve the issues for. And why this is particularly bad is because in that first like 1 meter from your access point, there's a huge change in like the signals that are coming out of it in like the drop off from the signals from there. And you got to think like your access points need to transmit to your client devices, and you want those Wi-Fi frames to be received and not corrupted, and vice versa, coming from the client devices to the access point. And when it's surrounded by so many of these materials in that first initial 1 meter of space, there's a high chance that it's going to cause like reflections, corruptions, and issues with your Wi-Fi. So you definitely want to suspend these down by about like a drop pole and at least 1 meter away from any kind of obstructions. So coverage is one thing. Secondary coverage is another thing, but also the physical way that you install the access points and having good quality RF signal can play a massive part. And then again, like just from doing the survey and going to the site, we can see again, we've got some gray issues up here, and we was able to find another access point that wasn't powered on. So we had some coverage issues up here, but again, by one of these massive big concrete beams. So we definitely want to address where the access points been placed, suspend them down, remove those materials, remove it from being near those materials that are causing us a bunch of issues. So we've had a look at like AP placement, primary coverage, and secondary coverage. I know a lot of you mentioned in the chat that you wanted to take a look at the next thing, look at channel interference. So I think that's a great thing to take a look at next for why a Wi-Fi network might be having some issues. So if we go to what's called the channel interference view in Ekahau, what you can see now is everything's kind of gone a bit gray. So what I want to also do is turn on this view here where it enables the channels on the access point. So we can see the channels now. And if I slide this slider up to the max here, it will show now in color like how many channel interference that we have. So if I hover my mouse over here, what you'll notice is that we actually have 8 of our own access points sharing the same channel on 5 gigahertz. And if I just zoom in a little bit here, let me just explain to you what we're seeing. So this refers to the 2.4 gigahertz channel, channel 1, and the color of it being like a dark purple means that that's the standard of Wi-Fi or the technology. So 802.11n. The pink means it's 802.11 AC or Wi-Fi 5, and then it's channel 60. Then when you see the at symbol in 80, it means it's using an 80 megahertz wide channel. So a standard channel width is 20 megahertz wide, and then you can bond it together to make it 40, and then 40 to 80 megahertz wide. And you can go to 160 or 320 now in Wi-Fi if you want to. So what's actually happened here is the person that had configured this decided to statically configure the access points, radios, and the channels and use really wide channels. But what do you notice about like what this access point here, for example? Does anybody know what's going on? Just looking at the the chat to see what everybody's saying. And yeah, so yeah, exactly that. So what we're noticing here is that with access points now, lots of the radios inside the access points, they're software defined. So they call it like flexible radio. So you can go from having a 2.4 and a 5 gigahertz radio, or a 5 gigahertz and a 5 gigahertz radio, or even in the newer ones now, you can have some 5 gigahertz, some 6 gigahertz, and you can be flexible with how you want to configure it. What has happened here is that the access point is gone into dual 5 gigahertz mode, and both radios are using 80 megahertz wide channels. So that means one access point alone is using up 160 megahertz of spectrum, which is a lot for 5 gigahertz, especially in the UK. So it doesn't leave us too much room for non-overlapping channels. And I'll be honest, like when you're reviewing a Wi-Fi network, should we be looking at just our own access points when it comes to channel interference? What do you think in the chat? Let me know. We have a very smart audience with us today, Mac. I don't... So let me change this now. So I'm going to change it from just looking at just all my networks to all measured. And you can see now it gets even worse in more places, because now we're taking into consideration all of the neighboring access points around us. So it gets a bit worse. But there was something else that's going on here, which is bit of an issue, especially when it comes to wider channels. So what I mentioned earlier about being able to bond channels together, I'm not sure. I don't want to move my mouse because it will get rid of that toaster pop-up. But if you can see down there, you can see all of the different access points. And you can see the channels that they're using. So 100, 104, 108, 112. But the 104 is in bold. Then you see the one below the 112 is in bold. And then below that, 100 is in bold. And then the one below that, 112 is in bold. And below that, 108 is in bold. Well, why is that? Why are they in bold? That's because when you bond channels together, let's say you go from 20 megahertz wide channels to 80 megahertz wide channels, that's basically, think of it as 420 megahertz wide channels combined. Only one of those channels can be what's called the primary channel. And why is that important? Because Wi-Fi is extremely polite. What happens in Wi-Fi's access points and client devices as well, they listen on the channel that they're on to see, is there another Wi-Fi device transmitting? If there is, then I will back off, wait for it to finish talking, then I'll try and access the medium. There's two checks that kind of happen. It's called preamble detect, energy detect. Preamble detect is like Mac and myself talking in English to each other. We both understand what each other's saying, and we know when we're going to stop talking, and the other person can then start talking. However, when it comes to the energy detect, imagine it's like Mac now starts talking Polish to me. I have no idea what he's saying. I struggle to understand him at the best of times, let alone if he starts talking Polish to me, I'm really not going to understand what he's saying. So much so I'm going to get to the point where like, you know what? I'm just going to transmit over him and try and say what I want to say anyway. So this is what we would refer to as like primary, secondary overlapping BSS. And this can really cause you problems on your 5 gigahertz network. And as well, you could potentially see this in 6 gigahertz too. So the best practice here when it comes to channel configurations, what we would recommend is use the widest channel you can until you can't. And what we mean by that, if we could have deployed 80 megahertz wide channels here and had no co-channel interference, that would have been completely fine and acceptable. However, because we've got so much co-channel interference on our own access points, it'd be better to go to a more narrow channel plan and have a more contention-free wireless network rather than having faster data rates. And let's be honest, in 5 gigahertz, we should have less channel interference on our own networks than we do on 2.4 gigahertz, since there's only 3 channels that don't overlap. So if I change this now to 2.4 gigahertz, I think we're all going to laugh, because how often is it you go and survey a Wi-Fi network in a busy city center and you see less channel interference on 2.4 gigahertz than you do on 5 gigahertz? So not something we come across too often. So that's quite a few things I think we've identified so far. Another thing that I want to show you is especially when we're talking about spectrum analysis. So we mentioned that earlier, and how much of a key role that can play to the performance of your network as well. And we just did one survey with the Sidekick between us. We had a Sidekick each in our iPad. And let me draw your attention now to the view of interferers of down here. So can you see on the map as well, we have these icons and this number 5. So it's a triangle icon and it says 5, and basically it's detecting interferers. So what we mean here is that it's detected something that's a non-Wi-Fi operating on the 5 gigahertz frequency band. And this is the impact that it's having. And this was their massive comms room in the lower ground floor. And you're thinking, oh, Matt, this doesn't look like it's impacting the network too much. Why is this a problem? Let me show you another view. Channel utilization. So how busy is the channel at that layer 1 physical energy? If I go to the inspect tab, what you can see here, if I click on one of our lovely little data points, you can see that these channels on 5 gigahertz are pretty much at 100% utilization. So let me translate that for you. Imagine that we were now trying to have a conversation and then Stu just pops back on and comes back with a foghorn and goes, ha, this the whole time, like screaming at us. That's like what is happening here. These devices just constantly transmitting. And not only are they just constantly transmitting, it's super loud. So this means our access points nearby, they'll be checking, oh, is there something happening on these channels? Ah, there is. I'm not even going to try and use them. And if you peek into the spectrum here, you can see all of these like narrow spikes. I'll zoom out a little bit. They're happening at the higher end of the 5 gigahertz frequency band. So you're thinking as well, oh, how often do you really find these like interferers? Like normally they're on like 2.4 gigahertz, but actually they are creeping in a lot on 5 gigahertz as well. They've started to move from 2.4 to 5 gigahertz. And these were on the lower ground floor, and they were also on the first floor, like in this comms room here, because basically they were monitoring the usage of who's going into the data center or the comms room to, obviously it's a priority place to make sure it's secured really well. So these were a few things. Is there anything else that you would like us to take a look at on this particular file. And I can show you because there's maybe like a couple, well, maybe like one or two other things, maybe from a configuration thing that we found as well that we could do to improve the performance of the network. Because it's not just coverage and channel interference that we can identify with Ekahau. Transmit power, that's a great thing as well. Okay, transmit power and signal to noise ratio, fine, no problem at all. What I'm actually going to do is I'm just going to turn this off for a second, and then what am I looking at? Signal to noise ratio. Okay, so here's the SNR values for you. You can see that it's, the quality of the Wi-Fi signal is really not that great. And if I click on one of these eye icons here, what you can see is we can see the SSIDs. We've changed them to say my SSID 1, 2, and 3. And we can see the spatial streams, the minimum basic rate that's currently being used, and all of the ones that are enabled. So just default basic rates are enabled. WPA2 is enabled. And 1 second, because I do think, actually, if I click on here, this one. And then I wanted to show you the SSIDs on 2.4 gigahertz as well. 1 second. I want to go to signal strength because someone said about transmit power. So wanted to check the transmit power of these radios. And I'm pretty sure that we do see them in here somewhere. Okay. But the thing that I wanted to point out to everybody is that the same SSIDs were configured on 2.4 and 5 gigahertz, and on 2.4 gigahertz as well. The minimum basic rates were enabled. So, like, why is that bad, and what does that mean? If you have the same network configured across both 2.4 and 5 gigahertz, it's always down to the client device on which access points to associate to or reassociate to. And if you give the client the chance to make a bad decision, like instead of be collecting on 5 gigahertz to go to 2.4 gigahertz, sometimes they're going to be able to do that. And when you've got the really low minimum basic rates enabled, all of the beacons and management frames, they're going to be sent at the lowest rate. So they'll be able to connect from really far away, transmit the data from really far away, and go really slow and bring down the performance of the network. So yeah, I would definitely recommend upping the MBR as well. So that was quite a lot of issues we were able to find from taking a look at this. I think Mac probably has been able to capture quite a few notes on this.
Quite a few. I have 1, 2, 3, 4, 5, 6, 7, 8, 9 things we could improve so far.
Yeah. Okay. Should I show that other one quickly, Mac, or should I jump back to the slides? What do you think?
Well, show us like the funny placement of few APs, and then let's move on.
Okay, fine. So we wanted to show you another example because you think, oh, this was probably like a one-off, right? This doesn't happen all the time. So let me show you another file and another example of an office in London that we got called out to take a look at. What you can see here is we're looking at the signal strength for these access points, and I'm just going to go to my networks and these access points. So I don't know what you notice here about the channels, but basically, let me just turn off the names. The channels here as well, they're using like a mixture of channel width. So some are on 40 megahertz wide and 5 gigahertz, some are on 80, some are on 20. So that means that you're going to get a really different experience when you go between these different access points. And not only that, the way the access points were actually installed is that every single one was basically installed on the wall like a clock. And yes, mate, does this look neater or nicer? I don't think so personally, but this has an impact on the way that the coverage comes out from the access point and what you're likely to see. And especially when you've got multiple access points installed in this way, it's not against best practices, and it's not the way we should be installing these types of access points. And we'll show you the impact and the change in coverage when you install the AP on a wall like a clock. But the one thing that I did want to show you, and let me, how do I bring this up without you seeing it first? Okay, 1 second. Because I want to see if you can figure out. I've been doing Wi-Fi surveys for a really long time, and I would actually say I'm an expert at finding access points. So after I've done a survey, I can see the coverage coming from the AP. I deem myself as a bit of an expert at locating where this access point is physically installed. But I want you to let me know in the chat, where in this picture do you think, come on,
That's smooth.
No, why is it not coming onto the screen?
Yeah,
Fine.
I remember first time using a computer.
Okay, here we go. So in this picture, where do you think the access point is installed? In his pockets. That's a small AP. Okay. Okay. Just watching everybody in the chat.
I've seen two correct answers there.
I've seen a couple of correct answers. So yeah, I did the survey. I could see the signal coming from the access point, and I was like, damn, where is this AP? So I had to admit defeat, get some help, and it turns out it was here. You're right, it was in the couch. So yes, and not only was it in the couch, it wasn't even there was a bracket in there for it. It wasn't even on the bracket. Ah, yes, these things happen.
But yeah,
And
if you sit on the couch, you're still probably all right. If I sit on it, there is no Wi-Fi.
exactly. So there can be big ramifications if you skip out any parts of Wi-Fi best practices when it comes to initial design, survey, validation, installation, optimization. It's easy to get it wrong. And the last thing before I jump back to the slides I'll show you is the massive impact of wireless rogue devices can have on your network. Let me show you up here. So these are the access points that were part of the Wi-Fi network. If I turn on all the access points that are found here, look at all the access points here. You're thinking, oh, are they actually really here? And the answer was yes. There were so many of these devices in the environment, all on 5 gigahertz using really wide channels as well. And what channel they using? 36. So there was a bunch of these devices all throughout this network that didn't need to have their Wi-Fi enabled. They're in these rooms. They're like, I think they were, I can't remember if they're printers or if they're TVs or something like that. They didn't need to have their wireless enabled. So one, they're a security vulnerability, and two, they were eating into that 5 gigahertz RF spectrum for the possible use that you could have had for your corporate connectivity. So yeah, quite a few things we found here. And let me jump back to slides then. I'll stop that share and then let's see what we found. So wow, we found lots of issues together. So we did a great job at manually analyzing this Wi-Fi network together. And I want to hand it over to you now, I think, Mac, right? So you're gonna have a quick look at some issues too.
Right. Okay, let me share my screen. There you go. You should see my screen now, hopefully.
Mhm.
So guys, Matthew has given us a great overview of a manual review of a measured survey data captured with Ekahau Sidekick and whatever Ekahau application that you use for capturing it. Hopefully you're using survey app on a mobile device. And this is the Helsinki office, okay? So first of all, why does it look so weird? Because we didn't use the floor plan. What we've done, we've used the autopilot survey to capture measured survey data. For those of
You
you not
used hold on a second, Mac. What survey mode did you use?
just go.
Okay,
What did I
not
say?
autopilot then. Autopilot. This is
Sorry.
just go.
Yeah, of course, it's just go. So the just go guys, it's a big novelty, okay, on the market, and it's extremely fun to use. You connect your Sidekick to your mobile device, Apple mobile device with Apple AR kit in it, and you can just go around, walk around, and it will draw, sketch the walls all around you. You don't need to put scale, you don't need to do anything. You just hit start button and walk around as you normally would. Just walk around and you're all good. Okay, so that's how we captured this particular survey data. It's fast and very, very accurate. Okay, so let's do a quick review of this survey, shall we? Quick manual review and then I will show you something cool in a second. So we are looking at the primary signal strength here. What does catch your attention? Is that a good primary signal strength or a bad primary signal strength? Too good, bad. Okay. Bad. Yep, okay, we are quite consistent. Yes, it's very bad. Like, look at 6 gigahertz. We have brand new APs in the office, and they should be able to do more. Why do you think we have crap primary coverage? What's happening there? Is the placement of the access points terrible? Is it dramatically bad? Or is there something else going on? Heavy walls. Too close to each other. Okay, so we have some heavy walls. This is heavy wall. These are heavy walls. We have like a toilet here. These are concrete walls all around here. Not high enough. They were high-ish enough. AP power placement. Okay, so I agree with everything. Okay, so some of the walls will block the signal. Some APs are too close to each other. However, this won't affect the primary coverage at all. But coming back to the conversation from the chat about the transmit and power levels, if I go to inspect and hit on any eye of my access points, we are using Cisco Meraki there. If you have broadcasting capabilities of names and QBSS fields like transmitting power level, number of associated stations, and so on and so forth. Some vendors can do it, including Cisco Meraki. You will see power broadcasted in the beacons, and we can see that there. Okay, so the power was very, very low. We had 3 dBs on that access point, random other access point 3 dBs as well, random another AP 2 dBs power level. It's very, very low. Okay, so very good. Transmit and power level was too low. Placement is not great. The access points, they are not massively well placed, too close to each other and so on. Okay, since we are looking at this view, what else catches your attention here? We are now looking at 6 gigahertz things. Is everything all right? Low MBR, supported rates. Great. Again, exactly that. So we are supporting base rate of 6 megs, which is a lowest available default on 5 and 6 gigahertz networks. And this will contribute to high management frames protection from beacons only. Okay, so if you have high CCI, then it might be a problem. Okay, what else can we check? Since we check the transmit and power levels, primary signal strength, let's look at secondary signal strength. What do you think of that, guys? Is that good? Will that affect something? It probably will affect our roaming a little bit, right? So we will be dropping off while moving around the network. If you lose the access point 1 or 2, then some places will have absolutely no Wi-Fi whatsoever. So that is fairly bad. Okay, so primary signal strength sucks, secondary signal strength sucks, transmit and power levels sucks. They are too low. Now, for the transmit and power levels, what would you set? What would you set your transmitting levels to with internal omnidirectional access points in a typical open space office? 12, 14, 17. Yep, good answers, guys. So the correct answer is try to match your clients, okay? Try to match your clients. There is no benefit in going too low with transmitting power level. There is a misconception of reducing transmitting power level to reduce the cross-channel interference on the same channel. You might a little bit contain the CCI on the access point level, but remember that hundreds of your clients connected to these access points around you, they will not lower the transmitting power levels. They will still be blasting at fixed 14, 17, 20 dBm, and they will create channel contention, client-induced channel contention without access points even, okay? Okay, very good. So talking about channels, anything captures your attention here? What do we have here on all 3 frequency bands, 2.4, 5, and 6 gigs? What would you change? Mix of 80s and 20s, that's correct. That's a very good answer. Turn off a few 2.4, that's another very good answer. Bandwidth, so channel width, a very good answer. Lots of channel 11. Okay, yes, very, very good answers. So yeah, look, we have the same channels, 11 and 11. On 5 gigahertz, we have partial overlapping here. So this is very bad. And also we have 80 megahertz, 20 megahertz, 20 megahertz, 80 megahertz again. If you have mismatched channel widths, then we are enforcing request to send, clear to send for every single frame sent in the network to avoid OBSS. Okay, so this will add to more protocol overhead. We don't want that, right? We don't want that. Additionally, this will create a massive stickiness issues, as Wes Purvis from Juniper Mist was talking about. He was talking about the Wi-Fi 6E adoption, which was a great presentation at WLPC in Prague, I think. Was it Phoenix? I can't remember. But the conclusion was that the clients, they are very biased towards wide channels. So if you have some access points on 80 megahertz and some on 20, most of the modern clients will stay connected to 80, okay? And that is very, very bad. Okay, so adding channels to the list. Now, next thing, let's check the channel interference. How do you like that? This is our 6 gigahertz, our 6 gigahertz. So we can improve that, right? Is it good? Is it bad? Yes, bad. Okay, not good, bad, definitely needs improvement. So this is for 6 gigahertz. Let's look at 5 gigahertz. So 5 gigahertz. Do we have problems on 5 gigahertz? Good, good. Some, no. Okay. So what are we looking at? We are looking at all my networks. So these are only our access points that are contributing to this visualization. Let's check all measured. So now we're looking at the CCI, where my access points, my neighbor's access points contribute, and the neighbor's access points contribute to all that crap on the screen. And this is really, really bad. Okay. So when I hover over somewhere in the middle of the office, I can see 10 channels overlapping. And this is not the worst overlapping. This is the most likely channel that you will be associated to that is overlapping here in this visualization. If I go, I don't know, like here in the corner, I can see 11. Okay, so this is bad. Yeah, Lucas, bleh, exactly. That looks awful. And 2.4, yeah, we don't even see a trace of color. So it's, oh my God, 12. Yeah, not too good. Okay, guys. So we've identified quite a lot of issues here straight away. Okay, so as you can see, we can do a great job doing a manual overview of all these issues, but we can be more efficient, and you don't need to have PhD in Wi-Fi to do so. So look at that. I will go to Optimizer, and I've opened the same project file. This is the same project file, Ekahau Lab Helsinki pre-optimizer V01. So that is, my friends, the same project file, And now I go to optimizer.ekahau.cloud and open the same project there. And we can use Ekahau to automatically tell us what is wrong with our network based on measured data. We can check it out manually, as we did for the last 40 minutes, but we don't have to. We can ask Optimizer to do it for us. So network status summary, we can see that primary coverage sucks. Secondary coverage, where is the secondary coverage? Geez.
I remember my first time using Optimizer too. It's the second card in on the right.
I still can't see that.
Second, like where primary coverage was, the one next to it on the right.
Secondary coverage. Yeah, there we go. Amazing. So this is in red, so it's even worse. Channel interference, bad. Coverage, noise, signal noise ratio, bad. Security, interfering devices, bad. Channel is bad. Management phrase protection, not bad. Security, good. Encryption, not bad. Everything else, it can be adjusted. So when I scroll down, this is our floor plan, a little bit different orientation, but this is the same thing. And I look at the primary coverage, I can see that it's bad. If we fix it, it can be fixed. So before it was all right-ish. After we fix it, it's amazing. Before, after, we can check that. Secondary signal strength, it's really bad. If we adjust our transmitting power levels, we can fix it, right? We can fix it. And we don't ask you to change the transmitting power levels to maximum available. We ask you to match your clients because that makes sense. Channel interference. So channel interference on 6 gigs or on 2.4, it was terrible. If we change our channels configuration, we can actually fix that. Same with the SNR. If we improve our coverage and reduce noise at the same time, we will improve SNR. Interfering devices, I can zoom in. We can see all the MAC addresses of the interfering devices. Interfering devices are all the APs that are not part of our Wi-Fi network. Fish tanks with Wi-Fi, you don't want to have them probably connected to a Wi-Fi network. Some smart printers and smart TVs blasting Wi-Fi across the office. We want to obviously remove them to remove not only the security risk, but also the overhead of those devices. Channel widths. We can see a mixture of 20s and 80s, wrong channel widths. And we tell you what to do, best practices, how to fix that stuff. Management frame protection, it was disabled everywhere on the SSIDs, which is good. On 2.4 and 5, you don't want to use MFP typically because your older devices won't be able to connect. 6 gigs, it has to be enabled because it's required by standard. MBR, we've seen that it was low, and yes, it is low. And encryption was good, okay, everywhere. It was correct encryption used. SSIDs configuration, we haven't talked a lot about it, but what we are highlighting here, look like we have UCLA SSID on 2.4 and 5. If you have dual band or tri-band SSIDs, your devices, and that's a fact, when they walk around the office, when you walk around the office with your phone, it will be jumping between 2.4 and 5 and 6, 2.4, 5 and 6. Not always, but sometimes. And when that happens, when you're on a voice conversation, your voice conversation is over. So the good practice here is to use single band SSIDs, okay? Single band SSIDs. If you do that, then you have just UCLA on 5 gigs, and everyone connecting to UCLA on 5 gigs will stay connected to 5 gigs. If you need to have that SSID on 2.4, call it UCLA slow, UCLA legacy, even freaking hide it, okay? Change the name and hide it, doesn't matter. Single band. Okay, so that was the optimizer. And then you have the action plan. So everything that we have discussed, you can see on a per radio basis how to improve those things. Okay, it can be quite daunting to look at, but it's actually very efficient. Ekahau optimizer is very efficient at telling you what to fix, how to fix it, what radio, what specific AP. So I hope that you enjoyed like the manual review versus automatic review. No rights or wrongs. I love doing manual reviews, but I appreciate that not everyone is extremely experienced with Wi-Fi, troubleshooting Wi-Fi, fixing, optimizing Wi-Fi. Optimizer can be your friend. I love Optimizer. Okay, so that concluded the reviewing section of this webinar. We have entire 7 minutes left to go through designs, which is a lot of time. I know, a lot of time. So let's open up a quick project file. And now let's do a quick design, shall we? So first of all, we have a big office space here, open space, typical modern office space there. And now before tri-band APs, before introduction of 6 gigs, we had to be very creative with wireless first environments using 2.4 and 5 only. We had to shoot from the top with directional antennas to chop up the bandwidth and create roaming boundaries. So the clients will be roaming between radios and we'll have an equal-ish spread of clients between all the different radios, increase capacity that way, reduce CCI that way a little bit. So we had to be creative. And now today with 6 gigahertz, it's a little bit simpler because we have 2.4 for IoT and old guests. We have 5 gigs for legacy corporate devices, 6 gigs for new corporate devices. And all these devices, they are spread between different frequency bands, which massively increases capacity. So let's take a look at a quick design thinking process here. I will select like Meraki Cisco 9166. How many APs do I need, guys, to cover this office space? How many do I need?
256.
12. Okay, let's see. So 256. Matthew is hardcore. Okay, let's put an access point here, an access point there, maybe one access point here. Can I? Oh, one access point there, one access point there. Not perfect. I really like also don't need to have like, you know, those areas included. So I can exclude those areas. So these are like the lifts, shafts, and toilets and stuff like that. So I don't care about those 3. But look what's happening. I have 5 APs, 5 APs, and I pretty much covered the entire office. Can I do 5 APs? Okay, maybe 6, But with those APs, if I even do my channels planning correctly, I have a correct channel plan now, optimal channel plan, and I have specified some capacity, okay, for those areas. I have specified some capacity. When I click on my areas, I can see that there are 200 clients on 5 and 6 gigahertz doing normal SLA. So it's actually quite low, the capacity for this office. So I smashed primary coverage. Secondary coverage will be pretty much non-existent. So that's the secondary coverage from our APs. So we have no roaming in the office. And also another problem is we have, ladies and gentlemen, problems with our capacity. So when I check capacity health against the requirements that I've set, it fails, okay? And there is nothing I can do about that. So we need to have more radios. So we've proven that with 5 or 6 APs, we can do a primary coverage. How many more APs do I need to cover it nicely in a modern network? Let's take a look. So I will start moving these APs. A very good rule, put access points in the rooms to contain the coverage, okay? You want to contain it a little bit. So I will be placing them in the rooms, okay? Then this is a canteen, so we need to have 2 APs in the canteen, okay? Now this is a space where clients will roam, so I need to have at least 2 APs that can hear each other faintly to use neighboring lease. It's a very important concept. We don't have time to talk about it too much, but it's a very important concept. Here are some offices, so I probably want to have some coverage there. I might put an access point there. Open space office, and it's very dense. I will check the distance between the APs, and the distance between them is like 12 meters. I'm comfortable with 12 meters between internal Omni APs. I would be comfortable even with like 11 or 10 meters. Now, a lot of people sitting there. There is like probably like a support with no windows. Why don't they have windows where HR always has windows, but never IT support? I don't know. Okay, and here we have a lot of people there, a lot of people here, plus some meeting rooms there. Auditorium probably requires to have 2 APs as well. And when I move this last access point here, I am getting quite happy with my design. Let's check the secondary signal strength quickly. This is just to show you a quick designing process, okay? I probably would like to have 1 more access point here, I think, for the transition purposes. These APs, they are quite far away from each other, and it's not good if you have people sitting here and enjoying their coffee. So I will have another one there. In the kitchen, depending on the requirements, I might drop another one if they are heavy Wi-Fi users. If not, probably they're all right without that particular access point. And everywhere else, I am happy. I might go a little bit denser here in the open space area where we have tons of seating, assuming that the office is quite heavily utilized. But basically, I am done with my design, and I am now quite happy. So next thing, I will calculate my channels. Okay, let's check the capacity first. I've added more APs, but have I increased my capacity? It's still failing because I haven't recalculated my APs channels. I have not recalculated APs channels. So let's do that quickly. Create. Ekahau is thinking. And what's going to happen? What's going to happen? Bam. With 20 APs, we've covered everything. We have nice capacity, and that's it. That concludes this demo. So I will stop sharing my screen. And if you have any questions, please shout. I know that was fast.
Lovely demo, Mac.
Okay, thank you. Stop sharing. So, Mr. Starling, back to you. I appreciate, guys, that we are approaching the end of the webinar. So not sure what to do because we have some exciting content. So we will speed up a little bit.
Yeah, I rejigged a few things around, Mac. Don't worry, we'll be fine. So these were the issues that I wrote down whilst Mac was doing his demo of manually analyzing it. So what's nice here is that Miko, if you don't know who he is, he's like, it's always his fault if something doesn't work in the Helsinki office. Someone mentioned that in the chat, so I made sure to write that down. But the really nice thing here is that everything that you were saying manually in the chat, based on Mac's analysis and what I was doing, Optimizer had all of that there for you as well. So it's kind of like your like little Wi-Fi expert best friend to checklist things for you to make sure you don't miss some stuff. So it's really nice to see that both in the manual analysis and also in Optimizer, we found some really cool stuff there. And one of the things that you might be wondering is like, how do we avoid having these deployment disasters and things go wrong? And really, it's like we need to follow like the best steps practices. If you skip any part of this, it can really mess up the performance of your Wi-Fi network. So what does it take to follow these best practices then? Well, if we break this down, the first step here in the initial survey is like a pre-design. So we want to, accurately understand the environment, and the attenuation of the materials, discover if there's any interferers, and know kind of how RF behaves in the environment. Then the next step is like making sure that the pre-design is right. So we want to make sure that we've got all of the access points that are really there, because if you think about it, pretty much we said earlier that most of our networks that we're going to do a design for a survey of, they have an existing Wi-Fi network. So getting your existing access points in their right locations and is really key, because we might want to reuse some of these cable runs and positions later on. So understanding the exact AP locations is really important. And we want to make sure we've got our predictive design accurately modeled. And why is this important? Because we want to use this data to make sure that the way we're going to place our access points is going to meet the coverage. Is there anything that we can do to really essentially make sure that the new Wi-Fi network is going to meet the requirements that we want? And also, if we can reutilize some of those existing cable runs and AP positions, it can save us some time and a bit of money. This step here is like number survey 3, the pre-deployment, the validation with an AP on a stick. I would say this is more for like challenging environments, or if you really want to see how a different or a new access point is going to behave, or a specific antenna, or it's a really challenging environment, you can do an AP on a stick and make sure that your design file is really matching what's happening in the environment. Also, it's a great opportunity to grab pictures of the proposed AP locations and give clear mounting instructions. I mean, if we think back to that first example I was showing you, if the person had gone to site and taken pictures or seen the exposed industrial ceiling, then surely they would have given much more clearer instructions for ways to install the access points and making sure the installation team can follow those. So then once we've done that, our final predictive model should really make sure that it matches perfectly with what we've found in the environment, from the validation survey to the simulation. It's very similar, very accurate with all of the materials. And then once it's done, we want to do a final validation survey and make sure it's optimized and the configuration is right as well. And if you follow these steps, then there's a very high chance that you're going to have a great performing Wi-Fi network. However, if you skip some of these really crucial elements of the Wi-Fi lifecycle, there's a chance that you're going to have big issues when it comes to the performance of your network. So, Mac, what are some of the best practices when it comes to configuration?
Well, let's talk about Wi-Fi best practices for configuration in less than 30 seconds, shall we? Okay, so guys, these are the 6 tips for configuring your Wi-Fi correctly. Grab a screenshot, think about it later a little bit more. I will keep it simple-ish. So number 1, transmitting power range. Match your clients. Typically with iPhones or Android phones, you will have negative gain on your antennas. So if they are transmitting at 20 dBm, the radios, you will see EIRP, radiated power, with antenna loss of 17, for example. Conversely, when you have Cisco AP, Aruba AP, whatever AP, internal Omni, and it has 14 dBm transmitting power level set, somewhere in the middle, like 25 milliwatts, with antenna gain of 3 dBs, EIRP 17, you have a client match. So like 14 is a sweet spot for most clients and most APs. But please do configure everything for your clients and be mindful of different access points and different gains on their antennas. 2, data rates. I wouldn't say I ever see where I would use 1, 2, or 6 megabits per second on any frequency band anymore. The lowest I would go is 12 megs in lower density networks, 24 megs on higher density networks. Remember that outside of data frames, everything else pretty much is transmitted at lowest available basic data rate, including all the beacons, associations, authentications, everything. So like every second frame is very slow, minimum basic rate. And then every second frame, which is a data frame in a Wi-Fi environment, typically will be very fast. So make the slow frames go a little bit faster. It will give you a better channel utilization, lower channel utilization. Speaking of channel utilization, guys, sustained channel utilization of 20% or more will screw up your voice communications, okay? So 20%, remember that number. Number 3, channel widths. If you're not sure, then use 20 megahertz on any frequency band, okay? If you know what you're doing, and if you can prove, and if you understand that you can go wider than 20 without creating channel contention overlapping on the same channel between your APs and your neighbor APs, then by all means go for it. You will have a faster Wi-Fi, but it's better to have slower Wi-Fi and no contention, so non-overlapping channels all around, than having a faster Wi-Fi when no one uses it. But when everyone gets to the office and starts using Wi-Fi on wider channels, overlapping channels, then it goes so slow, it's annoying. So 20 megahertz until you can go wider, okay? If you're not sure, use 20. 4, channel plan, dynamic or static? This is a very, very important question that we get asked very, very frequently. And the answer is, it depends. The older I get, or Matt gets, well, he's forever young, we tend to use static configuration more and more than dynamic, okay? Because with static, if you have an environment that doesn't have dynamically changing channels neighbors, I would go static. So a warehouse, airport, even an office where you own entire building and have not too many neighbors, I would go static. Sometimes in a typical office with tons of neighbors, you might want to use RRM just for channel choice. Set transmitting power levels to static, channel choice to dynamic, and channel widths to static, most likely 20 megahertz. And for voice, there is an additional thing. If it's voice only, extremely important, then you want to avoid DFS channels for faster discovery of new radios to jump to, okay? Now, number 5, layer 2 roaming only. Tons of vendors will allow you to configure layer 3 roaming. If you do that, it's slow roam by definition. Every time you jump between APs, it's slow. DHCP will be slow. So stick to layer 2. Okay, Wi-Fi is layer 2. There is no reason to go to layer 3 roaming typically. And number 6, roaming configuration. Extremely important. You might have the best Wi-Fi in the world, but if the roaming is slow, roaming means jumping between access points, then the clients using it will see your Wi-Fi as slow and you as an amateur. Okay, so roaming must be fast. And to do fast roaming, remember the transition access points, 2 APs that you think your devices will be roaming between, they have to see each other to some extent to be able to decode 802.11k action frames from the client, where the client can ask existing AP about its neighbors, and then it doesn't have to scan everything. It just scans this one neighbor and connects to it straight away. Important. If you are using 802.1x, so security with a radius server in the backend, you have to enable 802.11r fast transition for all .1x secured SSIDs to make sure that you authenticate with a radius server once, and then you jump between APs very fast just by doing 4-way handshake, which is very fast. We are talking without FT .111R, up to few seconds every time you roam or lost connectivity versus 50 milliseconds when you have that enabled. That's a massive, massive difference. So that's the configuration in 3 minutes.
Oh, I was going to say, well done for doing it in 30 seconds. All right. We also wanted to give you some tips on some Wi-Fi security best practices as well, because we really like you to be able to have lots of things you can take away and put into practical use from the webinar as well. So when it comes to security best practices, you might be thinking, why is coverage, like primary or secondary coverage, important when it comes to security best practices? And we had a really great webinar not too long ago, JJ, who is Jennifer Manila, who's an industry known Wi-Fi expert. And we were discussing this. And when you have poor
Jennifer Minella.
Okay, well, thank you for getting that right for me. I'm just going to refer to JJ. It's easier for me. But when it comes to the coverage, if you don't have great coverage, why is that a security threat? Because if you don't provide good coverage for your users, there's a chance that they could bring in their own devices and plug them into use themselves into your network, like consumer grade Wi-Fi, because corporate Wi-Fi is not very good. I need to do my video calls. I'm just going to bring in my own device and plug it in and connect to it, which could be a massive security vulnerability. Also, if you've not got great secondary coverage, as you roam between access points, if someone nearby sets up a honeypot SSID on an access point, there's a chance that your device may end up roaming to that device instead and then getting connected to that, getting your credentials harvested. So we want to try and avoid that as much as possible as well. Interferers, Wi-Fi, non-Wi-Fi, they can slow your Wi-Fi down or try and get you to be unauthorized connected from the Wi-Fi network to get you onto one of their devices instead. We want to ensure the configuration of our Wi-Fi network is up to scratch, and the security of our SSIDs, try and use as the most strongest security mechanism you can, WPA3, management frame protection, that kind of stuff. But we really need to ensure our client devices also support these things too. So that's the only kind of caveat there. Use .1x on your corporate SSIDs if you can as well. And keeping your physical securities, the physical part of your network secure as well. Even when it comes to like your wired ports, if you can turn them off, shut down the ports so people can't plug them in, make sure your APs are high away from people being able to just easily access and tamper with, because otherwise, yeah, people can really good. And I really like the thing there. It says on the bottom of number 5, don't rely on Macs or Mac. He can be very unsecure and not best practice. So we are at the end of the webinar now. I know we run over as always because we want to give you as much content as possible, but please do sign up for our next webinar. We are really excited for the product news that we've got to share with you. It's going to be really cool, and I would love for all of you here to be able to see it as soon as possible. So sign up. It's going to be in 2 weeks' time from today, and I think you're gonna absolutely love it. And on that note, do we have Stu or Dale any questions from the audience that we want to quickly answer? We're happy to stay on for a few extra minutes, try and answer as many questions as we can.
Yeah, not too many outstanding left, but one that I saw that you marked, and one question that was asked is how are we gathering transmit power information for access points?
Great question, and I'll answer that quickly. Most access points will advertise the transmit power in their beacon. So when we do the survey, the access points will be actually advertising on their radios what transmit power that they're using, and then we can record that information and we can see it in Ekahau AI Pro, and also Optimizer can see that too. However, there is some vendors that sometimes they don't do this, and it might be a configuration that you need to enable. And actually with the Meraki access points, you saw we did have the transmit power details of the access points too. So that was one that Mac was showing. So if they are supporting this and broadcasting this, we can capture it and detail it and see what they're using, and then we can then change those accordingly to either increase the transit power or turn it down, or maybe turn off a radio if it's not necessary. Stu, any other questions from you, my friend?
I think that was pretty much it. I think there was one that was also marked was maybe, I think it was oh yes. Making sure that when we are designing out there, we were talking about exclusion areas, and don't forget to make sure that you plan those exclusion areas. So even if you're going to exclude it, make sure you draw in the walls. That's usually often missed with a lot of folks, is that they forget, because if you just exclude an area, you want to make sure that the walls are in place, so that when you're designing, that's going to make sure that you're taking those areas into account of dB loss and whatnot, so you can plan around it.
That was a great tip, Stu.
There's a great question now in the chat. Pros and cons for optimizing for mobile devices. It seems to significantly change the design when enabled. A very short answer: do not use optimize for mobile when you do a design. Okay, do not do that. There is now a medium answer. When you design to a next 67 dBm, you are already taking into consideration the sensitivity loss of a typical mobile device. So next 67 from Sidekick 2 or from Free Space Pathflow's perspective, it will translate to like next 72, next 75 from a typical iPhone perspective. And that's absolutely fine. When you're designing primary coverage on next 67 and secondary coverage on next 67, you will never drop below that, next 75 when you roam. And that's absolutely fine, because typically that's a roaming threshold. Very, very short answer. However, for the surveys, if you have surveyed your environment with Ekahau Sidekick 2 and Free Space Pathflows and attenuation. So all the theoretical stuff that we use to calculate the waves propagation in our software and how Sidekick 2 measures it, it's pretty much identical. So when you measured your survey data with Ekahau Sidekick 2 and you want to understand what it would have looked like from my iPhone's perspective, you can quickly toggle it to understand it a little bit better. But typically, when it's next 67 primary and secondary, it doesn't matter too much.
Okay, I saw another question that came in. I think I just would answer very quickly. Maybe we can then wrap up after that. Is laptop, iPad, iPhone, or other, what device do you prefer to use while surveying? And if you asked me this a little while ago, I would have hands down said I love using my iPad. That's my go-to method for collecting survey data. I love the iPad. It's nice and mobile. I can use the pen for when I'm tapping on the map, and it's really great because I can easily snap photos of the environment and give you great context. And it's a great size. But now with our autopilot feature, and especially Just Go, I typically just use my iPhone. I have an iPhone 15 Pro, and it's got the USB-C connectivity and the LiDAR scanner. So that's how I can use Just Go, and a really great autopilot survey as well. And I can just go straight in USB-C from my iPhone to my Sidekick 2. So actually, my kind of go-to method now is probably iPhone, but other people's preferences change, and maybe Stu's preference. What is your preference, Stu? Is it iPhone, iPad, or laptop?
Laptop.
We'll lip read because he's forgotten to take himself off mute, but let's just pretend he said iPad. I know Stu likes to use his iPad most for doing surveys. So it can be a preference thing. Like sometimes you like a bit more screen real estate to see as you're doing your surveys. But for me, I can just like pan and zoom in with there you go, we can see his iPad. And I do it with the iPhone. So another question there, Mac is iPhone as well. Dale, how about you? What are you, iPhone, iPad, laptop?
Yeah, for me currently it's iPad. I don't have the iPhone 15 Pro yet, so it's my iPad Pro.
Yeah, fair enough. Okay, well then I think since we're like quarter of an hour over the webinar, I hope you all enjoyed it today. I think it was quite fun asking a lot of questions and doing the analysis together. You guys and girls did a great job at finding lots of issues with these projects manually, and hopefully you found some great value in that. We hope to see you all on the next webinar for the product announcement. Remember, tell your friends, tell your family, tell your dog. Make sure you're there. You want to see what's new, what's coming with Ekahau. Big thank you to all of you joining us, and Max, Drew, Dale, and the awesome Ekahau marketing team for putting this on. And we look forward to seeing you in a couple of weeks' times.
Thank you very much, guys. It was a blast as always. Have a lovely day, evening, morning, whatever.
Thank you, everyone.
Okay, bye-bye.